Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to solve the given differential equation using variation of parameters method in another way, part 2. So let's get going. Problem. Solve y double dash minus y equal to 2 by 1 plus e power x, or y2 minus y equal to 2 by 1 plus e power x, or d square y by dx square minus y equal to 2 by 1 plus e power x, or d square minus 1 into y equal to 2 by 1 plus e power x. So here we are given first equation y double dash minus y equal to 2 by 1 plus e power x. Here y double dash or y2 is nothing but d square y by dx square. Okay, all these equations are same. So this is an operator form of all the three equations. Okay, all the equations are same. Don't get confused. Given differential equation, y double dash minus y equal to 2 by 1 plus e power x, or we can write y double dash as y2. Okay, or we can write y2 or y double dash as d square y by dx square. And we'll write d square y by dx square in operator form. We'll get d square y, since d equals to derivative with respect to x. Here d is a differential operator, right? Now take y common from these two terms. We'll get d square minus 1 into y equal to 2 by 1 plus e power x. Consider the first equation as equation 1 and this as equation 2. The equation in operator form as equation 2 for our convenience. Okay, and here equation 2 is in operator form. Say f of d into y equal to some function of x, where f of d equal to d square minus 1 and r of x equals to 2 by 1 plus e power x, right? The homogeneous equation of equation 2 is, or the homogeneous form of equation 2 is f of d, that is d square minus 1 into y equal to 0. Consider it as equation 3. Now we'll find the solution of equation 3 using auxiliary equation, and later using the solution of equation 3 you will find the solution of equation 2 or equation 1. Okay, let's begin with the auxiliary equation now. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 1. Let's replace differential operator by m, so that we'll get f of m equal to m square minus 1. Now the auxiliary equation becomes m square minus 1 equals to 0. We can write this 1 as 1 square. From this we'll get m plus 1 into m minus 1 equals to 0, since m square minus 1 square is of a square minus b square form. Now we equate each factor to 0. When m plus 1 equal to 0, we'll get m equal to minus 1, and when m minus 1 equal to 0, we'll get m equal to plus 1. And m equal to minus 1 plus 1 are the roots of the auxiliary equation, which are real and distinct. The roots are real and distinct. We know that when two roots, say m1 and m2, are real and distinct, then the solution of homogeneous equation looks like one constant into e power 1 root into x plus another constant into e power another root into x. Okay, now let's write the solution of homogeneous equation. the solution of homogeneous equation. Equation 3 is given by y equal to one constant c3 into e power 1 root into x plus another constant into e power another root into x. Right? Then y equal to c3 into e power minus x plus c4 into e power x. Here we have used c3, c4 instead of c1 and c2 because we want c1 and c2 to appear in the last general solution. Okay. Now we got the solution of homogeneous equation, and using this equation we'll write the general solution of equation 1 just by replacing the constant c3, c4 or parameters by functions of x, a and b. Now we'll just replace c3 and c4 with functions a and b. A and b are functions of x, right? Let y equal to a e power minus x plus b e power x be the general solution of 1 or 2. Okay, both are same, right? Both the equations are same. So now here we need to find a and b. Okay, here a and b are functions of x, right? Where a and b are functions of x. We'll find a and b using the formula a dash equals to minus v into r of x by uv1 minus vu1, and b dash is given by u into r of x by uv1 minus v1, right? Now you can compare the solution of homogeneous equation with y equal to c3u plus c4v, or compare this with au plus bv, then you'll get u and v, where u equals to e power minus x and v equal to e power x. Okay, if you observe, we are having uv1 minus vu1 in both the formulas. So firstly we'll begin with uv1 minus vu1 and later we'll go for a dash and b dash. So here we need to find 5 things. First one uv1 minus vu1, and second one a dash, third one b dash, fourth one a, fifth one b. Okay, or after finding a dash you can find a, and after finding b dash you can find b. Okay, I'll go in this order. Here v1 is nothing but derivative of v or v dash, and u1 is nothing but derivative of u, or we can write it as u into derivative of v with respect to x, since u and v are functions of x. Okay, minus v into derivative of u with respect to x. This is equals to u, which is e power minus x, into derivative of v with respect to x minus v into derivative of u with respect to x. This is equals to e power minus x into derivative of e power x with respect to x is e power x minus e power x into derivative of e power minus x with respect to x is minus e power minus x. This is equals to e power minus x into e power x minus into minus plus e power x into e power minus x. We can write e power minus x as 1 by e power x. Here also we'll write e power minus x as 1 by e power x. E power x gets cancelled and we'll get 1 plus 1, which is equals to 2. Therefore uv1 minus vu1 equals to 2, which is non-zero. Okay, we'll find a dash using minus v into r of x by uv1 minus v1. This equals to minus v is e power x into r of x, 2 by 1 plus e power x by uv1 minus v1, which is 2. This is equals to minus e power, you can write it as 2 minus 2 e power x by 2 into 1 plus e power x. Okay, 2 gets cancelled and we'll get minus e power x by 1 plus e power x. You can find a here itself. Okay, you can write a dash as, so we got a dash finally. A dash is equals to minus e power x by 1 plus e power x. Using a dash we'll find a. We can write a dash as derivative of a with respect to x, because a dash is nothing but derivative of a with respect to x, equals to minus e power x by 1 plus e power x. Okay, here you'll separate the variables, and after separating the variables you can perform integration to get or to find a. Okay, fine. Let's find b dash. B dash is given by u into r of x by u v1 minus v1. This is equals to u e power minus x into r of x is 2 by 1 plus e power x by 2. You can write it as e power minus x by 2 into 2 by 1 plus e power x. Okay, or u by u v1 minus v1 into r of x, because r of x is a fraction, right? It will be much easier. 2 gets cancelled and we'll get e power minus x by 1 plus e power x. Okay, or we can write it as e power minus x into 1 by 1 plus e power x. Okay, which is equals to, now write e power minus x as 1 by e power x. We'll get 1 by e power x into 1 by 1 plus e power x, which is equals to 1 by e power x into 1 plus e power x. Right? Now, here in the numerator we are having 1, right? We can add and subtract e power x to this numerator. Then we'll get 1 plus e power x into 1 plus e power x minus e power x. So consider 1 plus e power x as one term, e power x as another term, and also e power x into 1 plus e power x as one term. Then we'll get, now we are having 2 terms in the numerator and 1 term in the denominator. So we'll write it as 1 plus e power x by e power x into 1 plus e power x minus e power x by e power x into 1 plus e power x. So here 1 plus e power x gets cancelled and e power x gets cancelled. Then we'll get b dash equals to 1 by e power x minus 1 by 1 plus e power x. Here also, here we got b dash, right? And we can write b dash as derivative of b with respect to x, and just separate the variables and then apply integration to find b. Okay, I got b dash. Let's now find a using a dash. We have a dash equals to minus e power x by 1 plus e power x, right? Since a dash is derivative of a with respect to x, equals to minus e power x by 1 plus e power x. Okay, now let's separate the variables by taking differential dx to RHS. We'll get minus e power x by 1 plus e power x into dx. So here the variables are separable. So we'll perform integration. If f of x equals to 1 plus e power x, then f dash of x will be derivative of 1. Derivative of a constant with respect to x is 0, plus derivative of e power x with respect to x is e power x. So f dash of x is e power x. We know that integral f dash of x by f of x dx is log mod f of x, so we'll get log f of x here, right? Now this integration becomes derivative, integral dA is a equal to minus integral, so here the integrand is of the form f dash of x, which is e power x, by f of x, which is 1 plus e power x, so we'll get log, we can just apply this formula, so we'll get log mod 1 plus e power x plus integral constant is c1, or a equal to minus log of 1 plus e power x plus c1. We got a. Let's now find b using b dash. We have b dash equals to 1 by e power x minus 1 by 1 plus e power x. We know that b dash is derivative of b with respect to x. Now we can separate the variables by taking differential dx to RHS. We'll get db equal to 1 by e power x minus 1 by 1 plus e power x into dx, right? Here the variables are separable, so we can perform integration. Here, in the integrand of last integral, we are having 1 by 1 plus e power x, right? We can write this e power x as 1 by e power minus x. Now take the LCM of these two. We'll get 1 by e power x, e power minus x plus 1 by e power minus x, which is equals to e power minus x by e power minus x plus 1. Right? Or we can write it as e power minus x by 1 plus e power minus x. So we can replace 1 by 1 plus e power x with e power minus x by 1 plus e power x, e power minus x. Since 1 by 1 plus e power x can be replaced with e power minus x by 1 plus e power minus x, okay, just by putting e power x by 1 by e power minus x. So we can write this as integral db equal to integral 1 by e power x is e power minus x into dx minus integral of, just replace the integrand with e power minus x by 1 plus e power minus x into dx. Now in the next step we'll take this minus inside the integral, then we'll get integral db equal to integral e power minus x dx plus integral minus e power minus x by 1 plus e power minus x into dx. Here in the integrand we are having minus e power minus x by 1 plus e power minus x, right? If f of x equals to 1 plus e power minus x, then f dash of x will be derivative of 1 with respect to x is 0 plus derivative of e power minus x with respect to x is minus e power minus x, which is equals to minus e power minus x. So here the integrand is of the form f dash of x by f of x. We know that integral f dash of x by f of x dx is log mod f of x, so we'll get log mod f of x here, right? Now let's perform integration. Integral db is b equal to integral e power minus x dx is e power minus x by minus 1 plus integral f dash of x by f of x is log mod f of x 1 plus e power minus x plus integral constant is c2. Then b equal to minus e power minus x plus log of 1 plus e power minus x plus c2. Now we got b and already we have a. So let's write the general solution. Therefore, The general solution is given by y equal to a e power minus x plus b e power x is equals to a minus log of 1 plus e power x plus c1 into e power minus x plus b minus e power minus x plus log of 1 plus e power minus x plus c2 into e power x is equals to minus e power minus x log of 1 plus e power x plus c1 e power minus x plus into minus minus e power x into e power minus x plus e power x into log of 1 plus e power minus x plus c2 e power x. This is equals to minus e power minus x log of 1 plus e power x plus c1 e power minus x. Here we are having e power x into e power minus x, right? Let's write e power minus x as 1 by e power x. Here e power x gets cancelled and we'll get 1. So just replace e power x into e power minus x with 1. We'll get minus 1 plus e power x log of 1 plus e power minus x plus c2 e power x. Or we can write it as y equal to, write the terms involving constants, c1 e power minus x plus c2 e power x minus 1 minus e power minus x log of 1 plus e power x plus e power x log of 1 plus e power minus x. So this completes part 2. So we have seen part 2 in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.